Can you hear me?
Yeah.
All right. So now, I was explaining refraction of wave, okay? And then I said is actually the bending of ray of light when it encounters a different medium. So I make use of this illustration, this example. This is air, this is a medium, okay? And this region is air. And then we have another medium, which is the glass. And then we have again the hair. So the incidence ray starts from the hair. Immediately it enters the glass, it has to bend. Okay, you can see the direction changes when it was in the hair, and then eventually change again the second time when it enters back the hair. So now from the position, the angle or the position from O to A, the ray of light from O to A, we call it the incident ray. Okay, then from A to B is the refracted ray. You can see the ray of light being refracted, okay? And at the same time, it emerges through B and C, okay? So now that is simple analysis of, refraction. So refraction of wave is the change in the direction of wave when it enters a different medium. Okay, hair is a medium, glass is a medium. We have water, which is also another medium. All right. So for this level, we won't be talking about the refractive index and some calculation, but you just need to understand the concept of what refraction is. So what we have there is refraction. Then the next question has been posed, and the next question says, what causes refraction? Okay, what actually causes the bending of the light when they encounter different media? So now, refraction is caused by change in the speed of light, okay, or change in the speed of the wave generally in another medium. So we have to note something. If light enters into a, you know, denser medium, a medium that is a bit heavier, okay, the light bends toward the normal because speed decreases from hair to glass. Now, between hair and glass, which one is denser? Glass tends to be denser than hair. So now when ray of light, move from, from hair and then to glass, okay, what's going to happen? The light, the ray of light or the wave generally will bend toward the normal, okay? So this is the incident ray. And, I explained this is the normal. Now, this is the ray that is being refracted now. This is the refracted ray. It bends and is bending toward this normal, okay? This is the normal. So this wave is bending toward the normal. So refracted ray bends toward the normal. So if the ray is traveling from a less dense medium, which is the air, we have the hair here, we have the hair, this part happens to be the hair, and here we have glass, okay? So, and glass is more denser than the hair. So when ray of light enters the glass, it bends, towards the normal, okay? And another situation is If, the light enters into a less dense medium, it bends away from the normal. Okay, so it enters a less dense medium, meaning it's moving from glass now. So this region now, we have the glass here. Okay, the whole of this place, we have the glass. Okay, so the ray of light is coming from a denser medium and it enters the air, which is less dense. So what's going to happen? The light, will bend away from the normal. This is the normal and is bending away from the normal. So you can see that the direction changes, the speed changes when move, when a ray of light travel from different, media. Okay, so that is in a nutshell the meaning of refraction. Okay, the next is the law of refraction. Before we explain the laws of refraction, I would like you to pen this down in your booklet. So, do you have any question before you start writing? Is this clear, or you want to ask question? Marvelous and Moyo,
It's clear.
It's clear.
Marvelous. Are you sure?
Yeah.
All right, good. So you guys can write now. You can write now. So in the course of writing, put your mind in what you're writing. I'm going to ask you to summarize for me in 1 minute what you've written in your note and what I've also explained. Yes, sir.
Do we have to draw the diagram?
Yes, please. Can I scroll down now?
Not yet.
Okay.
Then scroll down.
All right, I'm scrolling down. Marvelous. I hope you're okay
Okay.
with that. I don't write now. Hello, can you hear me?
Yes, sir.
Yes, sir.
Yeah, Moyo, can you explain briefly what you've written so far and what you've digested by the little explanation I made?
Um, I know that refraction of light is the bending of ray of light when it goes into a different medium. I also know
Continue,
about,
continue.
and it's almost the same thing as refraction of waves. It's the change in the direction of waves when it goes into a different medium.
Okay,
Then,
what happened when you move from a medium to another medium and the density?
huh?
What happened to the wave when it moved from different media respect to their density?
Okay. So when the density is length is small, it bends away from the normal
Mm-hmm.
because the speed increases.
Okay. How about marvelous? Can
So
you explain?
refraction is the bending of ray of light when it enters a different medium, and the refraction in waves is the change in direction of waves when it enters a different medium. And this change is caused because the speed of the wave or light changes because they enter a either less or more dense medium. So when they enter a more dense medium, the light wave bends towards the normal because the speed decreases because it's more dense, there is more volume, so the speed cannot move through quickly. But then when it enters a less dense medium, the light bends away because the speed increases.
All right, good. Thank you. Well done. Now let's quickly move to the law of refraction. So now for the law of refraction, the ratio of sine of the angle of incidence to the sine of angle of refraction is a constant for a given pair of medium. So that law, we know it as the Snell's law. Okay, that law is popularly known as the Snell's law. So the ratio of the sine of the angle of incidence, okay, to the sine of the angle of refraction, okay, is always a constant for a pair of medium. Now, look at this diagram. This angle here is the angle of incidence, okay? And this angle here is the angle of refraction, okay? So the ratio of the angle of incidence to the angle of, refraction is a constant. So that constant is what we refer to as the refractive index. So if you would do physics in A level, you will learn about refractive index, okay? Because each of those medium actually have different refractive value, okay? They have refractive index value. Water has a constant, air has its own, glass has its own. So that law is what we refer to as Snell's law, okay, named after the scientist. Now, what is the effect now? We quickly want to look at the effect of refraction. One is that refraction makes a long straight stick appear bent when they put in water. Okay, when you put them in water, it will appear as though it is bent. As you can see, here in the diagram, okay, a stick pencil or a lead pencil placed inside a beaker containing water. And when you look at it, it appears as though the pencil is broken. And no, it is not broken. That is just the apparent view, okay? And that explains refraction. So refraction makes a long straight object, appear bent when you put them in water. So this is one of the effects of refraction. Then second is refraction makes a pool of water to appear shallower, okay, than it appears. So it will make a pool of water, like I explained earlier, to appear as if it is not that deep, to appear as if it is very close, to the upper part. And it's a lie. It is until when jump into the water and then you discover yourself going down, down, down. Okay. So it is refraction that made it appear as if it is nearer, shallower. But meanwhile, it is deep. So the shallow, the shallow or the less or the apparent view of it is just a fake, but the real depth goes deep down. So it makes an object at the bottom of the pool of water appear raised in the water. Now, if a coin is thrown into the water, a clear water now, it will appear as though the coin is closer to outside. Or you put a coin, an object, inside a bath or a container that has water in it. So the object inside the water will appear, shallower, as if it's at the top, until you dip your hand into it and you find it down, down, down. So the apparent view is what you're seeing, and I explained refraction. So that's another effect. Another effect of refraction is the cause of the twinkle of the star. Okay, so refraction causes the twinkling of stars in a clear sky. Okay, to twinkle, lead to be, that's also another effect of refraction. Then another one is refraction causes formation of rainbow, okay? Having those seven color, the red color, the orange color, the yellow color, the green, blue, indigo, and violet. So refraction helps to spread white light and make them appear as though they are, you know, one singular. Okay, so that we have, and this will be the first class tax on the first thing we've done. But let me allow you pen this down in your booklet once more. Are you there?
Yeah.
Yes, sir.
Scrolling down. You don't need to draw the diagram here. I scroll down.
Yes, sir.
How do you say?
No.
No.
But the question said rational.
Okay, I'll be scrolling down now. All right, you should be done writing now. So I need you to answer this question to know how far we've gone. So the first question says, the follow of the question is 10 marks. First question is, what is refraction of light? And then the next question says, what causes refraction of light? Then the third question says, state the law of refraction. And the third question, how does a ray of light bend when it enters a dense medium? And then the next question says, how does a ray of light bend when it enters a less dense medium? And then the last question is, give 4 effects of refraction. So can you do this in 10 minutes? Can you do this in 10 minutes? Marvelous and Moyo.
Yes,
Yes,
sir.
sir.
Are you done with this?
Yes, sir.
Yes, sir.
All right, send it. Let me mark it. All right. So I will call it quits here. Now we'll be having another lesson now. So send it now. I'm going to mark it. I'm going to mark this one. All right. So do have a lovely night rest. Bye.
All right.
Bye.
You're welcome.